To produce finer nanostructures with better performance for nanoelectronic and nanophotonic devices, researchers are replacing chemical methods with simple, clean, compression-based fabrication.
This is really a new way to fabricate nanomaterials that's impossible for other chemical synthesis approach. So this is a game changer.
A team at Sandia National Laboratories has developed an innovative, green, economical fabrication process that reduces material defects and enables the development of new nanostructures and architectures not possible with current methods. The technology has piqued the interest of science, industry, and venture capital groups.
I have never seen or heard of this in our extensive interactions with some of the leading material scientists in the world. It really allows us to think about completely new materials and completely new solutions to problems that industry is facing across the board.
This is a revolutionary approach to dynamic compression of nanomaterials, and the concept of actually forming nanostructures from nanoparticles under this type of loading condition is new and very revolutionary.
Nanomaterials are widely used in consumer electronics and semiconductor devices. But most of these materials are manufactured using chemical synthesis methods that have serious problems, resulting in inflexible structures and harmful byproducts to dispose of. Sandia's technology is an environmentally friendly alternative, simple compression and no chemicals. The new process allows a much finer control of materials, enabling structures with novel characteristics and properties and fewer defects.
Semiconductor defects is very common. So created from the crystal growth process, from the mismatch between the crystal and the substrate. So we can use the mechanical compression to induce the atomic motion of the defects so that we can squeeze the defects away from the crystal. So dramatically reduce the yellow luminescence which related to the defect.
The yellow luminescence largely decreased after our compression, and that is a powerful indication, direct indication of the defect reduction using this technique.
At a certain pressure, we can control the nanoparticle separation distance to achieve the couplings between the particles, for example, the energy and charge transfer, so that they can show new physics that impossible for current chemical synthesis approach.
Given the fact that this pressure-induced fabrication can initiate, phase changes, band gap changes, miscibility changes, then fundamentally that allows it to address all fundamental electrical and optical physical properties of material. So that's what I like about it.
In these nanowire lasers, normally their lasing wavelengths are limited by their band gap, which is their intrinsic property of these semiconductor materials. However, using this powerful technique under the compression, we can tune this semiconductor's band gap as we want it. Therefore, we can achieve some wavelengths that is not possible in these materials.
The team subjected materials to different levels and durations of pressure at Sandia's dynamic compression facility. This environment provided proof that the process could be integrated into existing industrial production lines.
A high-pressure, rapidly applied pulse is an attractive alternative for fabricating these nanostructures. We have done demonstration tests here at the facility using our electromagnetic driver, and by compressing an emulsion containing a suspension of nanoparticles, we're able to definitively demonstrate the formation of nanostructures, such as fine wires, from these embedded particles in the emulsion.
These machines are big, of course, but in industry, the same techniques transfer to much smaller systems because the compression is still there. This just happened to be what we had on hand to try the techniques.
I think the potential at this point is probably unlimited. There are many applications where nanostructures can be fabricated using this technique and consequently applied to nano antenna, nano pressure sensors, optical components. I think the sky's the limit.